Hello everyone. Today we will study the topic Indices and Logarithm. Chapter 2, Class 11, Applied Maths. Before starting with the questions, I want you to understand few terms. Fractional indices. What is fractional indices? We know the indices are the powers. So fractional indices when we have the powers in terms of fractions. Here I can see 1 upon n is a fraction. So I can write it as root to the nth power. Let's take up some other example. If I say a to the power 1 upon 2, I can write it as root a. If I say 1 upon 3, I can write it as cube root a. If I say a to the power 1 upon 4, then it is fourth root and so on. So, a to the power 1 upon n is nth root of a. Similarly, if you have a to the power m upon n, can I write this as a to the power m 1 upon n? So, this will be nth root of a to the power m. I hope it is clear. Radical sign. Now, again, I am not new to this symbol, but I am new to the term radical sign. Basically, the sign is said to be a radical sign. In our previous classes, we have learnt this as root a. Basically, this is default to. So, we say square root. This is cube root and so on. So, this sign is a radical sign which we use for square root, cube root or any nth root. Basic rules of exponents. We have learnt in our previous classes all the rules. Let's review quickly. Whenever I have same base, different powers, I add the power. Whenever I have same base, in division, I subtract the power. Power to the power, we always multiply both the powers. When I have same power, with the multiplication of two numbers, I can split. Similarly, I can do the splitting in terms of division also. Anything to the power 1 is not required to be written. Anything to the power 0 is always 1. Any base with negative power can turn negative. Now, and a to the power minus n is basically the reciprocal of the base and the power turns positive. So, I can write this as a to the power n also. Here, I see the same. Reciprocating the base, power turns positive. A upon b to the negative power, b upon a positive power. So, I hope all the rules are reviewed now. Let's move on to the very first question. 81 upon 16 minus 3 upon 4. So, here I can see minus 3 upon 4 has a base 4. Think of a number which can be written with the power 4. 81. I can write 81 as 3 to the power 4. Also 16 as 2 to the power 4. To the power minus 3 upon 4. Here, combining them will give me 4 to the power minus 3 upon 4. As we have learnt, power to the power, it always get multiply. So, it is 4 into minus 3 upon 4. I can reduce 4 and 4 and I am left only with 3 upon 2 to the power minus 3. I have a negative power. So, I will reciprocate the base and my power turns positive. So, which is 2 into 2 into 2, 8. 3 into 3 into 3 is 27. This is my final answer. The next question. 3a upon b inverse. Now, b inverse, I have just gone to the rule which says if I reciprocate the power turns positive. So, this term can be written as 3a into b plus similarly 2b as it is a. What can I see now? 3ab plus 2ab. 3ab plus 2ab will give me 5ab. Let's start with this question. Here, 8 to the power 4 upon 3. So, we'll think of a number which can be written with the power 3. So, it is 2 upon 2 to the power 3 to the power minus 3, 4 upon 3 divided by 2 to the power minus 2 whole to the power 1 upon 2. Now I can see here this is minus 4 because 3 and 3 will be reduced here, right? Now divided by 2 to the power minus 2 to the power 1 upon 2. Now same base division will subtract. So minus 4 minus of minus 2 whole to the power 1 upon 2. So this turns out to be minus 4 plus 2 whole to the power 1 upon 2. Now my answer is 2 to the power minus 2 to the power 1 upon 2. I can again reduce them, and now I have 2 to the power minus 1 left. Reciprocate and it turns positive. My answer is 1 upon 2. Next, 9 to the power 5 upon 2 minus 3 into 5 to the power 0 minus 1 upon 81 minus 1 upon 2. Now looking at the answer, what I can see is 9 can be written as 3 to the power 2, which is to the power 5 upon 2, minus 3 multiply 5 to the power 0 is anything to the power 0 is 1. Again 81. Can I write 81 as 9 to the power 2 minus 1 upon 2? Now this can reduce on the very first step. So what am I left is 3 to the power 5 minus 3 minus 9 to the power minus 2 reciprocating minus 1 by 2. Again reduce. Now 3 to the power 5 minus 3 minus 9 to the power minus of minus 1. Here I can see there is a subtraction sign, so nothing can be done in terms of loss. So I have to find 3 to the power 5, 2, 4, 3, 3 into 3 into 3 into 3 into 3, minus 3 minus 9. This turns out to be positive, right? Now subtract 240 minus 9, which is 231. My final answer. Next, here there are multiple numbers, so let's go with them one by one. If I see here, can I observe that this turns 2 directly, because this is 2 to the power 2 to the power 1 by 2. I am removing all the nth roots and writing as a fractional indices. Now 256 can be written as which to the power 4? 4 to the power 4 and 1 upon 4 upon 64. Again 4 to the power 3, 1 upon 3. I have not chosen the prime factors. I have converted them according to their nth root. Now this can be written as 2 to the power 2, reciprocating the power turns positive. Now can I reduce here directly? That makes my work easy. So I am left with 2 multiplied by 4 upon 4 minus 4. 4 and 4 reduced. So 2 minus 4. My answer is minus 2. I hope it is clear. Let's move on to the next. The question seems quite long, but we'll go step by step. Now 3 to the power 4. So 81, 3 to the power 4, 3 to the power 4. 32, 2 to the power minus 5. I hope it is clear. I have reciprocated 1 upon 32. Right? So my power is minus 5. Minus 2 by 5. Plus 8 can be written as 2 to the power 3. 1 upon 3. Now 1 upon 2. Why to write 1 upon 2? I'll reciprocate. And this is 1. I have applied many laws in one step only. Now reducing. This will be reduced. This will be reduced. So what is left now? 3 to the power 3 minus 2 to the power minus of minus 2 means 2 plus 2 into 2 into 1. So this will go once. 27 minus 4 plus 4. I can reduce plus 4 minus 4 and I am left only with 27 as my answer. So long question turns simpler. Next. Okay, so what I can see here? I can see 3 as a base, 4 as a base, 9 as a base, 2 as a base, and none of them can be written with the power of 7. Right? So what I'll do now? I'll use a different strategy here. 3 to the power minus 6 to the power 1 upon 7. I have split this power. I'll do the same for the next. 4 to the power minus 3 to the power 1 upon 7. Multiply 9 to the power 3 to the power 1 upon 7. Again 2 to the power 6 to the power 1 upon 7. Upon. Here I can see in the denominator there is plus ka sign. So no rule can be applied here. I'll simply solve it. 4 plus 1 plus 1 upon 4. Right. Now moving on to the numerator again. Here now what is common here? Everybody is the power, every number is with the power 1 upon 7. So I'll combine all of them. So this is 9 to the power 3, 2 to the power 6 and whole to the power 1 upon 7. Upon, if I see down, this is 5, 1 upon 4. Now, you have to understand one thing which I am telling you separately, not in the question. 3 to the power minus 6 is 1 upon 3 to the power 6. 4 to the power minus 3 is 2 to the power 2 to the power minus 3. So, this is 2 to the power minus 6, which is 1 upon 2 to the power 6. Next term, 9 to the power 3. 9 to the power 3 is 3 to the power 2 to the power 3. So, 3 to the power 6. And this stands same. So, here if you see, my question turns out to be 1 upon 3 to the power 6 multiply 2 to the 1 upon 2 to the power 6 multiply 3 to the power 6 into 2 to the power 6 to the power 1 upon 7. Here, now, I can reduce this and this and this. Denominator is to be solved. Now, if I see this all turns 1. So, 1 to the power 1 upon 7 is 1. 1 upon 21 upon 4. So, my answer is 4 upon 21. Final answer. I hope the question is clear. We use a different way of solving this question. Move on to the next question. Here I can see the powers is in terms of x. Let's start solving it with the same strategy with the base 5. So 5, I can see 2 powers, I'll multiply. 25. 5 to the power 2 to the power minus 7 plus 2x. 125, 5 to the power 3 with the power 2x. So if you see here, I have converted all the terms in terms of 5. The base is 5 for all now. So 2x plus 12 multiply 5 minus 14 plus 4x multiplying both the powers and 5 to the power 6x. Next step. Since they both are in multiplication and this is in division. So what I'll do is 5, the ones which are in multiplication will be added. Right. And the division one will be subtracted. Now, observe. This will be reduced. And these both will be solved and I will get 5 to the power minus 2. 5 to the power minus 2 means 5 to the power 2, which is 1 upon 25, and my answer is here. Next question. This question is all in variable. It seems difficult, but we'll go step by step to make it easy. Now, here, the base is same, the base is same, the base is same. So can I write x to the power m minus n, since it is in division, with the power L, multiply x to the power n minus L with the power m, multiply x to the power L minus m to the power n. Now multiply both the powers. Here I'll multiply powers x ml minus nl, multiply x mn minus ml, multiply nl minus mn. Now since it is in division, now I'll add all the powers, and I hope you all have already observed that it will now be reduced. This 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus, what am I left now? X to the power 0, which is 1, my final answer. Easy busy? Again, variable question. Use the same strategy, but here there are many numbers. So what I'll see and observe very first is a plus b, a minus b, b plus c, b minus c, c plus a, c minus a. So do you remember a plus b, a minus b is a square minus b square, the identity we have studied in our previous class? Let's apply the same. Now I am writing directly a square minus b square upon x to the power c to the power a minus b. X b square minus c square, x to the power a b minus c. X c plus a, c minus a, x to the power b c minus a. Now let's combine all the numerators and the denominators. So x to the power a square minus b square plus b square minus c square plus, I forgot to write here c square minus, so c square minus a square. So c square minus a square upon x ca minus cb plus ab minus ac plus bc minus ab. So what do I get? Here plus minus, plus minus, plus minus. Here plus ca, can you see? Yes. Minus bc plus ab minus, what is left over now? Nothing. Here also, so I get 1 as my final answer. Such a complex question turns to simple number 1. I hope the question is clear. So let's start with the next question now. Here I can see value of a is given, b is given, c is given, and I have to prove this. Whenever I have proof ka question, I always start with LHS or RHS. Here I'll start with LHS, so I'll write LHS a to the power q minus r, b to the power r minus p, c to the power p minus q. I'll put the value of a here, which is xy p minus 1 q minus r. Value of b xy q minus 1 to the power r minus p. C xy r minus 1 to the power p minus q. Now let's split them. So what I'll get is x to the power q minus r, y to the power p minus 1 q minus r, x to the power r minus p, y to the power q minus 1 r minus p, x to the power p minus q, y to the power r minus 1 p minus q. Since there is no calculation with the base x, so I'll combine x ka power. So it is, I'll combine this and this term. So q minus r minus p plus p minus q, and then y. For y, I have to multiply this, which I am doing directly and writing as pq minus pr minus q plus r. Now the next, this. So what I'll get is qr minus pq minus r plus p. Then this, which is plus rp minus q minus p plus q. So let's study and see. Here I can reduce this and this. Here pq plus pq minus pq minus pr here minus q plus, oh, this is not minus this, so I cannot reduce here, plus r minus r plus qr minus qr. I cannot see minus qr. Oh, this is minus qr. It is little combined with the sign. So plus p minus p plus q minus q. So everything is reduced and I am left with x to the power 0, y to the power 0, which is 1 into 1, and my answer is 1. I hope this is all clear. Next question. Again I can see here a to the power cz is given to me, b to the power ax is given to me, c to the power by is given to me. I'll take up 1 and put the value of the rest. So let's take a to the power cz. Do I have the value of c here? Yes, I have the value. So I'll put the value of c. So what do I get? B to the power yz. Now do I have the value of b here? Yes, I have. So I'll again use the value of b, which is a to the power x yz, which is equal to a to the power x y z. Power to the power will multiply. Now if you see, the base is same and we have an equal to sign. So what do I get? 1 is equal to x y z, which is to be proven, and we'll write hence proved. Question is easy. So let's start with this question. Here I can see 2 to the power x, 3 to the power y, 6 to the power minus z is, they all are equal. So whenever I have such question, what I do is, I will take all of them. Let all of them is equal to k. So what does that give me? 2 is equal to k to the power 1 upon x. 3 is equal to k to the power 1 upon y. 6 is equal to k to the power minus 1 upon z. Now, also I know that 2 into 3 is equal to 6. Put all the values from here in terms of k. So, k to the power 1 upon x, k to the power 1 upon y, and k to the power minus 1 upon z. Oops, I have written this as plus. This is multiplication. Okay. So, since it is multiplication, the powers will be added. So, k to the power minus 1 upon z. Now, bases are same. Can I equate the powers? 1 upon x plus 1 upon y will be equal to minus 1 upon z. Transposing, 1 upon x, 1 upon y plus 1 upon z is equal to 0, and hence proved. I hope the question is clear. Any question of such type is supposed to be done in the same way. So this is one more same type of question where I can see 2 to the power x is equal to 3 to the power y is equal to 12 to the power z. So my first step is assuming 2 to the power x is equal to 3 to the power y is equal to 12 to the power z is equal to k. That gives me 2 ka value is k 1 upon x, 3 ka value is k 1 upon y, and 12 is equal to k to the power 1 upon z. Now what is the prime factorization? For 12, 12 is equal to 2 to the power 2 into 3. Put the values in terms of k. So, k 1 upon z is equal to 2, 2 upon x since it is 2 ka square into k 1 upon y. Let's start combining the powers. So, this is k, right? So, k to the power 2 upon x plus 1 upon y. Now 1 upon z, that implies 1 upon z is equal to 2 upon x plus 1 upon z. Now what I'll do next is 1 upon z minus 1 upon y is equal to 2 upon x. Taking LCM, x minus z upon yz is equal to 2 upon x. Implies transposing both of them. X is equal to, this will go up to yz and this will come down. Did I get what I wanted? Yes. So, hence proved. Let's move on to the next. Solve the equation for x. Here, I can see this is 5 to the power 2x plus 3. But this is 1. To find out the answer, I need the same base. Can I write 1 as 5 to the power 0? Yes, anything to the power 0 is 1. That implies with the fact that powers will be same now. So 2x is equal to minus 3 and x is minus 3 upon 2. Simple. Now this question is 13 to the power root x. So 13 to the power root x is minus ka sign, no loss can be applied. So 4 into 4 into 4 is 256. 3 into 3 into 3 into 3 is 81 minus 6. So that gives me minus 169. So 13 to the power root x is equal to 13 to the power 2. Implies root x is equal to 2. Squaring both sides. What do I get? X is equal to 4. My answer. Next question. Here 3 to the power 5 is x plus 1 upon 2 since it is root ka sign, and 125 is 5 to the power 3, 27 is 3 to the power 3. So I can write here the powers are, here the bases are, this is 3 upon 5 and this is 5 upon 3. So what I'll do is I'll make it 3 upon 5 and the power turns negative. The power turns negative when we reciprocate the base. So that implies x plus 1 upon 2 is equal to minus 3. X plus 1 is equal to minus 6 and x is equal to minus 7 as the answer. Next, 4 is, let's find out the LCM here. So it will be 4x plus 1 upon 2 and this is to be multiplied by 1 upon 3. So this is 2 to the power 5. So I need this also as 2. So 2 to the power 2, 4x plus 1 upon 2 into 1 upon 3. This 2 will be reduced and I am left with 2 to the power 4x plus 1 upon 3 and 2 to the power minus 5. Reciprocate implies 4x plus 1 upon 3 minus 5. 4x plus 1 is equal to minus 15. 4x is equal to minus 16 and x is equal to minus 4 as the answer. I hope finding x the questions are clear. This question is little complex, so please understand carefully. Here I have multiple terms. So the simple strategy is convert to the prime factor as a base. So this can be written as 3 to the power 2 to the power n. This is already with the prime, this is already with the prime, this is 3 to the power 3 to the power n upon 3 to the power 3m, already nothing to be changed, this is, and this is 3 to the power 3. So I have converted all the numbers into the prime factors. Now let's start combining them. I can see this is in multiplication. So what I'll do is I'll combine the powers. 3 to the power 2n plus 2 plus n minus 3 to the power 3n upon 3 to the power 3m into 2 to the power 3. Nothing can be done. This is 3 to the power minus 3 if I reciprocate. Here there is a minus ka sign. So whenever I have minus ka sign in exponents question, there is no alternate other than taking common. So I'll take 3 to the power 3n common. So what these? Let's not do the shortcut. It may confuse you. So what I'll do is I'll write 3 to the power n plus 2 minus 3 to the power 3n upon 3 to the power 3m into 2 to the power 3. I am not changing anything. I am just rewriting it. Now, can you see this 3 and 3n as common? So now in the next step, I'll take 3 to the power 3n common. So when I take this common, I am left with only 3 to the power 2 here. Minus 1 because nothing is left here. 3 to the power 3m into 2 to the power 3 is equal to 3 to the power minus 3. Now, if you solve 3 to the power 3n, this turns out to be 8. 3 to the power 3m, this is also 8, 2 to the power 3 and 3 to the power minus 3. So, this will be reduced and I can now write 3 to the power 3m minus 3 to the power m is equal to 3 to the power minus 3. Now combine the powers. What do I get? 3n minus 3m is equal to minus 3. 3 is taken common is equal to 3 into minus 1. This 3 is reduced and I am left with n minus m is equal to minus 1, which is n is equal to n plus 1. Hence proved. I hope the question is clear.